So our goal for this is to take this. This is called general form, which is kind of things are everywhere. And the goal is to put it back in standard form, which is what we've been working with, which is the x minus h squared plus y minus k squared equals r squared. That's the form that we want to put it back in because then we use this to find the radius. We just change the signs of the numbers on the inside. And then we use, I'm sorry, that was completely wrong. We use this to find the center. My apologies about that. Not perfect. And then we use this to find the radius. But the point I was trying to make is we're trying to get it back in that form so that we can get the center and the radius so we can visualize the circle on a graph. So what we're going to do, the reason we want the variables on one side and the number on the other is that's how we're going to get it into this form because we're going to complete the square, which the discovery activity you did last week will help with that. So we're going to get it to this form and factor it. And then the number on the other side, that's going to turn into our radius. So for this first one, that has already happened. I've got all my x's and my y's on this side, and then I have just the plain number on this side. So now what we're going to do is further rearrange it just a little bit and complete the square so that we can easily factor. So what I'm going to do is I'm going to take this x squared and this 30x, and I'm going to put those together because we're going to complete the square, which is what that blank is, and we'll come back to that. Then we're going to put the y squared and the 14y side by side because, again, we're going to complete the square. Now, we know for any equation what I do on the left, I have to do on the right. So I'm going to add these two random numbers in, which I can do, and I'm going to prove to you why here in just a second. But what I do on one side, I have to do on the other. So those have to be included on that other side. Okay? So then what we're going to do is we're going to decide what goes in these blanks. So we know for it to be a perfect square trinomial, it is the middle number doubled and then the last number squared. So what I'm going to do is I'm going to cut that 30 in half, which is 15, and then I'm going to square it, which is going to give me a 225, which is what 15 squared is. So plus 225 on both sides. Then what I'm going to do is I am going to cut the 14 in half, which is 7. Then I'm going to square it, which will be 49, and we'll add that to both sides. Now, let me pause for a second and talk about why it's okay to do that. So let's talk about this equation, x plus 1 equals 3, right? X is 2. 2 plus 1 is 3. Well, it doesn't change anything if I do x plus 1 plus 4 equals 3 plus 4. X is still going to be 2 because this would become x plus 5. This would become 7. X is still 2. It does not change the value of your variable whatsoever as long as you do it to both sides of the equal sign. So that was just kind of a little side note as to why I could do that. Okay, why I can just randomly put these numbers as long as I put them on both sides. So now what we're going to do is we're going to factor. So remember I said cut the 30 in half, which is 15, and square it. So to factor that, it would be x plus 15 squared. You could FOIL it out and check it if you don't believe me. Over here, cut the 14 in half, that's 7. Square it, that's 49. So that's y plus 7 squared. Equals, now we're going to take all of these numbers and combine them, which is 9. Now it is in standard form. Now I can find the center and the radius. So the center would be negative 15 and negative 7. And the radius would be the square root of 9, which is 3. So this is one of the hardest things we've done so far this year. just basically completing the square. And some of you may be going, well, Miss Bowling, if I know this is going to be 15, why do I even need the 225? Well, the reason being is because I need it on that side to get the 9 to make the radius 3. Now, let me prove to you that all this works, okay? What I'm going to do is I'm going to go to Desmos, good old trusty Desmos, and I'm going to type in my original problem and then my converted equation. And if they're both meaning the same thing, they're the same circle, which of course they would be, they're going to overlap in Desmos. They're just going to graph the same exact thing. So let's go to Desmos here. So x squared plus y squared, that is not what I wanted, squared, plus 30x plus 14y equals negative 265. So let me zoom this out so we can see it. So there it is. And we can see our radius of 3. And then you could also see our center there. So there's your negative 15. And then it was at negative 7 if you wanted to count that. So there we can check our answers there too, which is pretty amazing. So now what I'm going to do is I'm going to type in x plus 15 squared plus y plus 7 squared equals 9. And that's just my converted equation in standard form. So original, then converted, and it graphs it over the exact same. They completely overlap. So here, there, they overlap completely. So they are the exact same equation. They make the exact same circle. When I look at the first equation, I couldn't tell what the center and the radius was. When I look at the standard form, I can, and then you complete the square to find out.